Hello everyone. In this video, I'm going to solve a problem on convolution using the convolution integral, and I want to use the graphical um, method in order to find the convolution between h and x, as you can see in this question. So this is problem 15.43 part B. So in these kind of question, if I give you such a question in exam, that we have, for example, an exponential function, I will give you the expression of that exponential function. So for example, if I give you a u of t that you can see here, you should know the expression. If you have a ramp function, you should know the expression, but for the exponential functions, I'm going to tell you what that function is representing. Okay? All right, so what I have to do for convolution is to flip and shift one of my functions and then move it towards my other function. So here I'm going to make x of negative lambda. So I have to mirror my x with respect to the y-axis. This will be my x of negative lambda, right? Then what I have to do, I need to make x of t minus lambda so I can use the convolution integral. So here, if I want to make x of t minus lambda, I'm writing this in parentheses because I don't want it to be like mixed with this one. So the purple line will show me x of t minus lambda. What does that mean? It means that I have to shift by t. All right. So this is t because I shifted from 0 to t, and that will be x of t minus lambda. Now I have to move my x of t minus lambda towards h of t. So let me draw both of them in the same graph. I have h of t like this, and I know that this exponential function will be equal to 0 when t goes to infinity. So that will be like this, continuing until infinity. And then if I bring my x of t minus lambda in, then if this is 2, and let's say this is 1, so this will be my function, my x of t minus lambda, right? So here I have to find the overlap between my two functions, right, in order to write the convolution integral. And I know that t is between 0 and 1 here. So what I have to do here is to find this overlap, which is this part. Okay, let me write the integral. So we said that the limit is between 0 and 1, right? So keep it like 1 as 1 for now. Let me go through the function and see what would be inside the integral. So what is x of t minus lambda? That is equal to 1 in this interval, right? And what is h of t here? It is 2e to the negative t. So that 0 to 1 is actually the limits of my t, not the limits of my integral, right? Why? Because where they have overlap will be the limits of my integral. Where they don't have any overlap, that integral is equal to 0. So this is the limit of my integral from 0 to t. All right. And actually this was supposed to be h of lambda. So this is e to the negative lambda d lambda. Right? So let's see what would the result of this integral is minus 2e to the negative lambda from 0 to t, and that would be minus 2e to the negative t. Okay? So this will be my minus 2e to the negative t actually, plus 2e to the 0, right? Because the lower limit was 0. So that would be 2 minus 2e to the negative t, and it will be equal to 1 minus e to the negative t. So this is when t is between 0 and 1. Okay, but let's see if I move t more toward right. So t will, I will increase t, but you see that this is u of, actually this was u of t. So this function is infinite, right? It will always be equal to 1. Only when, so if you go back here at x of t, you know that u of t is equal to 0, but after t equal to 0, it's always equal to 1, all the way to infinity. So if I mirror it, you see that this function, it has that infinity part over here, right? So this will be always equal to infinity. And then at the same time, 2e to the negative t will continue until infinity. Why? Because if t goes to infinity, then that function will be equal to 0. So if I move t, basically if I move ax of t minus lambda to the right, I will always have the same overlap with that other function. This function, the purple function, will be always equal to 1. The red function will be always equal to 2e to the negative t. Okay? So for this specific function, y of t will be always equal to, y of t is always equal to 1 minus e to the negative t. Why? Because both functions continue until infinity. All right, so this is for all t greater than 0, because our integral is from 0 to t. All right. Okay, so if you have any questions, you can ask me in the comments down below, and see you in the next video.